Hello, welcome to In 5 Minutes. Now last we have solved the problem of P JFET. Now we have N channel JFET. Now if you see in the question, they have given us an N channel JFET. So this becomes your gate, this is your drain, and this is your source. Since the arrow is pointing towards, it is N JFET. Now to identify the configuration, again you have common source, common drain, common gate configuration. From these three, which is the configuration? Look at the input port. If you see, input is applied, can say Vi is applied to the gate. From where we are taking output? From source. Output we are taking from source. So which terminal is left out from these three is we have used gate and source. So it is common drain configuration for N JFET. Right. Now what does the question says? Consider the source follower, which is nothing but common drain circuit JFET amplifier in figure, with transistor parameter IDSS as 10 milliampere, VPS -5. Since lambda is given, we need to consider the value of RO. Now in this case, RO is not infinite, we need to consider the value of RO. How to find the value of RO is lambda into IDQ, the whole inverse will give you the value of RO. VDD is given as 12 volts. And RL is given as 0.5 kilo ohms. They have told us to design the circuit such that the input resistance Rin is 100 kilo ohms. That is, the resistance seen from this point should be 100 kilo ohms, and at that time the Q point is at IDQ, which is half of IDSS. That means if IDSS is 10 milliamperes, your value of IDQ will be 5 milliamperes. And your VDSQ is half of VDD, so the value of VDSQ will be 12 upon 2, which will be 6 volts. So these are the values given for the first part. First we'll complete the first part, then we'll go for the second part. So we need to design the circuit such that these values are satisfied. That means we need to find the value of RS, R1 and R2. Now to start with the analysis, you know Shockley's equation. It gives the relation between ID and VGS as ID equals to IDSS 1 minus VGS by VP the whole square. The value of IDQ we have got half of IDSS. That means we know the value of IDS 5 milliamperes. Value of IDSS is given as 10 milliamperes. 1 minus VGS we don't know, and VP is given as -5, the whole square. So this will get 5 equals to 10, 1 plus VGS by 5 the whole square. So this will be half equals to 1 plus, or you can say 5 plus VGS by 5 the whole square. So it will be under root 1 by 2 equals to, or if you are expanding this then also it is fine, 5 plus VGS by 5. So on solving you will get two values of VGS. So the value of VGS will be, can say two values, one is minus 1.46 volts and the second is minus 8.535. Always get the two values of VGS, because whenever you have quadratic equation, rather than solving by this method, you don't solve by the quadratic equation, that is expanding this. It will be half equals to a plus b the whole square will be 25 plus 10 VGS plus VGS square upon 25. So on solving this you will get the two roots for VGS. Now the value which is less than VP, that we need to select. Now in this case VP is given as -5 volts, The value which is less than minus 5 volts, that is the accurate value. Since minus 1.46 volts is less than minus 5, we'll select this value. So we are discarding this value since it is greater than Vp, right? So the reason also you should know. So we got VGS as minus 1.46 volts, right?